Hi everyone. Through this class, we are going to study about the direct form realization, cascade realization, and linear phase realization of digital FIR filters. In general, the time domain representation of nth order FIR system is given by y of n equal to sigma m equal to 0 to n minus 1 bm x of n minus m. By expanding this, we can write this equation like this. And the Z domain representations of FIR system is given by H of Z equal to Y of Z by X of Z. That is equal to B0 plus B1 Z raised to minus 1 plus B2 Z raised to minus 2 plus dash dash Bn minus 1 Z raised to minus of n minus 1. The computations in these equations can be arranged into various equivalent sets of difference equations. And this leads to different types of structures for realizing FIR systems. Some of the structures of the system gives a direct relation between time domain equation and Z domain equation. The different types of structures for realizing FIR systems are: first one, direct form realization; second one, cascade realization; third one, linear phase realization. First, we consider the direct form realization of FIR system. It is also called as transversal structure realization of FIR system. For realizing this, consider the difference equation governing FIR system. We know that y of n is b0 x of n plus b1 x of n minus 1 plus b2 x of n minus 2 plus dash dash bn minus 1 x of n minus 1, or this term is b n minus 1 x of n minus capital N plus 1. Here the input given is x of n and mark this output as y of n. For realizing this first term, multiply this x of n with b0. So here we get b0 x of n. Then take the inverse Z transform of x of n. So we get x of n minus 1. Multiply it with b1. Then we get b1 x of n minus 1. Then again take the inverse Z transform of x of n minus 1. So we get x of n minus 2. Multiply it with b2. So here it is b2 x of n minus 2. Continue this till we get x of n minus n plus 1 and multiply it with bn minus 1. Add all these terms together. Then we get the output as y of n. Second form of realization is cascaded form of realization. For this, consider the Z domain representation of FIR system. We know that H of Z is Y of Z by X of Z. That is equal to B0 plus B1 Z raised to minus 1 plus B2 Z raised to minus 2 plus dash dash Bn minus 1 Z raised to minus of n minus 1. This transfer function is n minus 1th order polynomial in Z. This polynomial can be factorized into first and second order factors, and the transfer function can be expressed as a product of first and second order factors. Hence, we can write this h of z as h1 of z into h2 of z into h3 of z into up to this hm of z. Or we can write it as pi I equal to 1 to m hi of z. Here this hi of z can be first order or second order. If it is second order, then we can write this hi of z as c0i plus c1i z raised to minus 1 plus c2i z raised to minus 2. If it is first order polynomial, then it can be written as hi of z equal to c0i plus c1i z raised to minus 1. The individual second order and first order sections we can realize either by direct form structure or cascaded form structure. The number of calculations and the memory requirement depends on the realization of individual sections. In cascaded form of realization, we want to realize the individual sections H1, H2, H3, etc. Suppose Hi of Z is second order, then it is given by this equation. So we can realize this section for I equal to 1 first. Then we want to realize for I equal to 2 and we can continue up to I equal to M. So here the input given is X of n and the output marked as Y of n. So we can construct this cascaded form of realization like this. The third form of realization is linear phase realization. And for this linear phase FIR filter, impulse response H of n is H of n minus 1 minus n. And the transfer function H of Z is the Z transform of impulse response H of n. That is equal to sigma n equal to 0 to n minus 1 H of n Z raised to minus n. And there are two different cases. First we consider n when it is even. Then our H of Z, the sigma we can split into two, one from 0 to n by 2 minus 1 and next one from sigma n by 2 to n minus 1. So first sigma n equal to 0 to n by 2 minus 1, that we can write it as n minus 2 by 2. H of n is raised to minus n plus sigma n equal to n by 2 to n minus 1 h of n is raised to minus n. And in this sigma, we can change this by n equal to 0 limit by taking n as n minus 1 minus n. So, by putting this value, the sigma changes into 0 to n by 2 minus 1 or n minus 2 by 2. Then this n changes into n minus 1 minus this n. So it is h of n minus 1 minus n, and z raised to this n also changes to n minus 1 minus n. Now we know that this n minus 1 minus n is this h of n is h of n minus 1 minus n. So we can write this as h of n and this is a term like this. Then we can see that these two sigmas, their limits are same. So we can take it outside. H of n is also common. So sigma n equal to 0 to n minus 2 by 2 h of n. Then into z raised to minus n plus z raised to minus of n minus 1 minus n. Now take n as 8. Then we know that h of n is h of 7 minus n. So when n equal to 0, it is h of 0, that is h of 7 minus 0, that is h of 7. When n equal to 1, h of 1 is h of 6. N equal to 2, h of 2 is h of 5. And n equal to 3, h of 3 is h of 7 minus 3, that is h of 4. Now put all these values in this h of z. H of z, we know that it is sigma n equal to 0 to n minus 2 by 2 h of n, z raised to minus n plus z raised to minus of n minus 1 minus n. Here this limit n is 8. So 8 minus 2 divided by 2, that is 3. So sigma n equal to 0 to 3 h of n z raised to minus n plus z raised to n minus 1, that is 7 minus n. Now first put n as 0. So it is equal to h of 0 into z raised to 0 plus z raised to minus 7. Second one, n as 1. Then it is h of 1 into z raised to minus 1 plus z raised to minus 6. Then n is 2. H of 2 into z raised to minus 2 plus z raised to minus 5. N as 3. H of 3 into z raised to minus 3 plus z raised to minus 4. This is our h of z. The transfer function h of z is y of z by x of z. Therefore, y of z means the z transform of output y of n. That is equal to x of z into our h of z. Then by taking the inverse Z transform of y of z, we get y of n. So y of n is this h of 0 into inverse Z transform of this x of z, that is our x of n, plus inverse Z transform of z raised to minus 7 x of z, that is x of n minus 7. And the second term as x of 1 into x of n minus 1 plus x of n minus 6 plus h of 2 into x of n minus 2 plus x of n minus 5 plus h of 3 into x of n minus 3 plus x of n minus 4. And we can realize this like this. So here our input is x of n and the output is y of n. And for this, first we want to take the inverse Z transform of x of n, then we get x of n minus 1. Then again we take inverse Z transform, that is x of n minus 2. Then again it is x of n minus 3. Again it is x of n minus 4. Again when we take this, it is x of n minus 5. Then again it is x of n minus 6. Again we take this inverse Z transform. It is x of n minus 7. Now all the previous inputs and present input is ready. Now we want to combine this x of n and this x of n minus 7. So we add this x of n and x of n minus 7. Then we want to multiply it with h of 0. So we multiply it with h of 0. And for the second term, we want to combine x of n minus 1 and x of n minus 6. So from x of n minus 6 and this x of n minus 1, we add them together and we multiply it with h of 1. Then for this third term, we want to combine x of n minus 2 and x of n minus 5. So they are added together and we multiply it with h of 2. And for the last term, x of n minus 3 and x of n minus 4, they are added and it is multiplied with this h of 3. And all these terms are added together, then we get our output as y of n. This is for n which is equal to 8. For linear phase realization, in general, for n equal to capital N itself, then we can realize it like this. Now, for the second case, that is when n is odd, our h of z is sigma n equal to 0 to n minus 1. That limit we can split into 3. The first one is from n equal to 0 to n by 2 minus 3 by 2. H of n is z raised to minus n. Then next one is n equal to n by 2 minus 1 by 2. A single value. Substituting that, it is equal to h of n by 2 minus 1 by 2. That we can write it as n minus 1 whole divided by 2. Then is z raised to minus of n minus 1 divided by 2. Then plus. Next limit is for n equal to n by 2 plus 1 by 2. That is n plus 1 by 2 to n minus 1. H of n is z raised to minus n. Take this last term first, then it is equal to h of n minus 1 by 2 is z raised to minus n minus 1 by 2. And here we can change the limit starting from 0 by putting n as n minus 1 minus this n. Therefore, the two limits are now same. So we can take it outside. So sigma n equal to 0 to n minus 3 by 2. H of n is common. So we can take it outside. Then here we have z raised to minus n. Then inside this it is h of n. H of n is n minus 1 minus the small n. So it is z raised to minus of n minus 1 minus this n. And for linear phase, we know that h of n is h of n minus 1 minus n. And if our n value, that is 7, then we have this h of n, then h of 7 minus 1, that is 6 minus n. Now, if we put our n as 0, it is h of 0 equal to h of 6. When n equal to 1, it is h of 1 is h of 5. N equal to 2, it is h of 2 equal to h of 4. When n equal to 3, then h of 3 is h of 6 minus 3, that is again h of 3. So our h of z for this case, it is h of n minus 1 divided by 2 z raised to minus of n minus 1 by 2 plus sigma n equal to 0 to n minus 3 by 2 h of n z raised to minus n plus z raised to minus of n minus 1 minus n equal to h of 7 minus 1 by 2, that is h of 3, z raised to this minus 3 plus sigma n equal to 0 to 4 by 2, that is 2 h of n z raised to minus n plus z raised to minus of 6 minus n. Then first we take n as 0, then it is h of 0 into z raised to 0 plus z raised to minus 6. Then plus next value of n, it is 1, so h of 1 into z raised to minus 1 plus z raised to minus 5 plus next value n as 2, h of 2 z raised to minus 2 plus z raised to minus 4 plus this h of 3 z raised to minus 3. We know that h of z is y of z by x of z. Therefore, y of z is h of z into x of z. So we get the expression like this. Y of z is the z transform of output sequence y of n. Therefore, y of n is inverse z transform of y of z. When we take the inverse z transform, then y of n equal to h of 0 into x of n plus x of n minus 6 plus h of 1 into x of n minus 1 plus x of n minus 5 plus h of 2 into x of n minus 2 plus x of n minus 4 plus h of 3 into x of n minus 3. So our input sequence, that is marked as x of n, and the output sequence as y of n. First we want to find out the previous inputs. For this we take the inverse z transform. Then it will be x of n minus 1. Again taking inverse z transform, it is x of n minus 2. Again it is x of n minus 3. We continue this till we get our x of n minus 6. Then for getting the first term, here it is x of n plus x of n minus 6. So we add this x of n and x of n minus 6 together. Then we multiply it with h of 0. For the second term, we add x of n minus 1 and x of n minus 5 together. Then we multiply it with h of 1. Then for the third term, we add x of n minus 2 and x of n minus 4 together. Then we multiply it with h of 2. Then for the last term, we take this x of n minus 3. Then we multiply it with h of 3. Then all these outputs, they are added together to get our output sequence y of n. In general, when n equal to n, the structure realization is like this.